Hi guys, today let's discuss the LeetCode question 46 permutations. Given an array nums of distinct integers, return all possible permutations. You can return the answer in any order. So permutations is the arrangement of the given numbers. So let's go to the example 1. So the example 1 nums is equal to 1, 2, 3. Since the length of this nums is 3, we will be getting 3 factorial arrangements, so which is 6. So the output is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and 3, 1, 2, and 3, 2, 1. So let's go to the example 2. So the input nums is 0, 1. So there will be 2 factorial arrangements, so which is 2. So the output is 0, 1 and 1, 0. And the example 3 is nums is 1 and the output is also 1. So there is only one factorial, which is one arrangement possible. Let's go to the constraint section as well. So the constraints is nums.length ranges from 1 to 6 and nums of I, the values can be from minus 10 to 10 and all the integers of nums are unique. So there are no corner cases to this. So there exists at least nums.length will be at least 1 and it is less than or equal to 6, and nums is from minus 10 to 10 and they are all unique. So we need not handle any of the corner cases. I hope it is very clear from this question description. Let's go into the explanation part of it. For the purpose of explanation, let's consider the nums to be 1, 2, 3. So with this 1, 2, 3, let's look at the recursion tree and how we are going to arrive at all the permutations. So from this we will be getting 3 branches, out of which the first branch is going to be 1 and 2, 3. So here 1 represents, let's assume this one as a permutation, and 2, 3 as a remainder of the nums. So which means that all the nums are not utilized and the first one is going to be the permutation. And the second branch is going to be 2 and 1, 3, and the third branch is going to be 3 and 1, 2. Now let's look at the recursion tree for the next level. So where we are going to pass, we are going to split the 2, 3 further, and we are going to arrive at 2 more branches. And the 2 branches that we arrive at are 1, 2 and 3. And 1, 3 and 2. So these 2 represents the first one, 1, 2 and 1, 3 represents the permutation, and the remainder of nums is 3 and 2. Let's look at the different branches that we are going to arrive from 2 and 1, 3. So we are going to arrive at 2, 1 and 3 and 2, 3 and 1. Let's look at the third branch, that is 3 and 1, 2. So we are going to arrive at 3, 1 and 2 and 3, 2 and 1. So from this level we can see the remainder of nums is just, the length of it is just 1. So which means that we are reaching the end of this recursion tree. So the last step is going to be, the first one we are going to get a combination 1, 2, 3, and for the next one we are going to get a permutation of 1, 3, 2, and for the next one we are going to get a permutation of 2, 1, 3, and for the next one we are going to get a permutation of 2, 3, 1, and for the next one we are going to get a permutation of 3, 1, 2, and for the last one we are going to get a permutation of 3, 2, 1. Finally we are going to store all of these things. And finally we will be arriving at the required output. I hope it is very clear from this explanation. Let's go into the coding part of it. Let's start by creating an empty permutations list that is going to store the results. It is going to be an empty list. Then we are going to create a helper function in order to aid with these permutations. So we are going to store 2 arguments inside this. So the first argument is going to be the permutation, and the next argument is going to be the remainder of nums. If the length of permutation equal to length of nums. So which means that we have used all the numbers or integers that are provided in the nums in the permutation. So which means that we have formed a permutation and we can store it in the permutations list. So we are going to append permutations dot append. We are going to append this permutation that we have computed. Else, if the length is not equal, which means that there is the remainder underscore nums list is not empty, and which means that there are further elements that needs to be added to this permutation. So in that case, we are going to loop through this remainder nums for I in range of length of remainder underscore nums, and we are going to call this helper function on the permutation plus remainder underscore nums of I. We are going to add this particular I index value of the remainder nums to this permutation, and then we are going to just reduce the size of this remainder underscore nums. So that is going to be remainder underscore nums of, we are going to just exclude this I value from it. So it is going to be remainder underscore nums. Here it will be I plus 1. Okay. Yeah, I think that's it. We are going to call this helper function. Initially, the permutation is going to be an empty list, and remainder nums is going to be nums. And finally, we are going to return the permutations. Yeah, I hope we are done. Let's quickly run the code. Yeah, can only concatenate list, not int to list. Yeah, I made a mistake. So here this is going to be an integer value. So we are going to add this one also in the form of a list. Now let's quickly run the code. Yeah, let's quickly submit it as well. Yeah, it is accepted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.